Alright, welcome back to part 4 of Jogaming. So, just want to go back to something I was talking about last time. So, um, I said this is the scalar projection, not the vector projection, in this equation right here. Just want to say that if you were to simplify this equation, you get uv cos theta over v, right? Well, that's just u cos theta. So it's almost like it's just getting the cosine part, which is the angle part, like I showed here, the angle right here. This would the cosine would closely align. Like, let's say we got two vectors here, and I want to project right here. So let's see. So it'd be 90-degree angle, but like this is actually a bad angle. See, this is like kind of hard to do. So like, actually, I think projection just works with like small angles. Yeah, I think so. Hold on. Sorry now. So this is a case. The angle right here, and we draw a right triangle. Since this is right, the cosine has to be this angle part of the thing. So that's kind of why this gives you the direction of the projected. Anyways, enough talk about we gotta talk about cross products. So the cross product denoted by you vect this x sign, crap, v vector, and in Calc 3 or linear algebra, this is something you do. A, B, C, D, E, F, G, H, I, and you get the determinant of this determinant by multiplying this A net value with this. Well, let me show you in a 2D. So A, B, C, D. You get the determinant by multiplying and subtracting these two numbers. So AD minus BC is the determinant. And for here, for a 3D matrix, it would be this multiplied by a number. So like this constant number, I guess. Yeah. But what's this got to do with vectors? Well, you may say vectors and matrices are related, but that's not what we're talking about right now. We're talking about vector cross product, not determinants. Determinant is more like gives you the magnitude. Determinant I just showed you right there. It's more like giving the hut to. Know what I'm saying? Anyway, what am I saying? So high. Anyways, so um, basically, this is equal to. Now the reason why this is a determinant, because in matrices, this deals with more numbers and variables, not vectors inside a matrix. And this is your unit vectors. And then we're gonna say U equals ABC. V equals DC. So A, B, C, D, E, F. Now this is why it's different from a determinant, because that's because this has a vector and this is a number in the same matrix. So it's not a determinant, because a determinant is a number and we're getting a vector from this. So this is what you get. So like I said, you just this number multiplied I, or vector I meant, times the determinant of these two. Now remember this equation. This is minus and this is j, and it's the rule is like you kind of just to figure out which numbers variables you actually use. You draw you draw lines, like straight lines coming up and down to tell you these are the lines you exclude, and then you point it down to here and it goes from left to right and down, up, down. So that's why B, or that's not yet, but like, let's draw it out real quick. And then the next one is this, and so we get A, F, C, D. And then it's plus now. Okay, and then K, it's A, B, D, E. Now we get the determinant of these. Determinant is going from left to right and top to bottom. It's like that. So left top, right bottom, or yeah, that's the priority. Left top, right bottom. So B times F, BF, and then minus CE minus J, and then it's AF minus CD plus K AC minus BD. Now, this kind of makes a whole lot of nothing sense, because it doesn't make a lot of sense. Anyways, this also can just be equal to BF CE AF CD AC minus BC. Oh, like this has a negative here on the side. So, yeah, that's what it's equal to, and you're kind of asking, what is this whole process? What did we just do? Why did we do this? Don't worry about why you had to do this. You probably learn this later. Well, I didn't, but despite what you learned or not, this process is just called getting the cross product, and the cross product is a vector, as you can see. And the special thing about this vector is, let's say you had these two vectors right here, U, V. Well, the resulting vector, let's call it N, points to, it is both perpendicular to these two vectors. So that means if this vector, say these vectors are on the 2D plane, like so, that means N has to be in the third dimension, right here. Let's draw the third dimension, and N would be pointing there as right angles to both of them, because they're the intersection of two things, and then, I don't know. Yeah. But also, by the way, the magnitude of N is also equal to the parallelogram created when you make a parallelogram with the two vectors. So this is another equation for the area of a parallelogram also, just if you want to know that. And let's just say that the equation. Wait, let's actually, I'm going too far. Hold on. It's 10 minutes. Alright. So if the question ever asks you for the equation of a parallelogram and you are given two vectors, I think now you know. Now let me check real quick about my notes.
especially when it comes
Alright,
to
I'm
snack
checking my
time.
notes.
Ralph's shoppers don't have to
Alright.
choose between
So,
refined and
we gotta
peanut
say,
blend. With our
last
potato
video,
chips
or
and
last couple
pretzels, you
videos,
never compromise on
A
satisfying
vector
treats.
times B
And you never
vector
compromise your budget either with
has the
lower than low
commutative property
prices.
of
Hand it to Ralph's
being
shoppers. You
equal
never
to
compromise.
B
Download the Ralph's
dot
app to start
A,
shopping and saving
but
today.
A
Ralph's,
cross B is
fresh for
not
everyone.
equal to B
Do you
cross
remember if the
A,
recipe says 2 or 3 cups of water? Let me video call
and
Abuela.
in
How
fact,
are you,
it's
mija? Hey,
actually
let me go to the living
A
room.
times
Here, Carlitos' place, but try the
B
basement. The
equals
recipe was with 2 cups of water.
negative B
Social media
cross
no lives.
A.
What? Live like a gigillionaire.
I'm not gonna
Get
show you the
internet in
proof
more
of that,
corners of your
but
home with AT&T
that's
Fiber with all
that's
fiber.
generally it.
AT&T.
They're not
Connecting changes everything.
equal. If you swap the
AT&T
places,
Fiber limited
they're gonna be the
availability in select
negative of
areas
each
requires
other.
AT&T extended Wi-Fi coverage service for additional monthly charge.
Yeah. Hold on. Let me see stuff. Yeah. Oh yeah. That also means that if you get the dot product, if you get the dot product from, get the dot product of the new vector with the either of these vectors, um, because I just told you both, this vector is both orthogonal or right angled or perpendicular to both these vectors. That means that the dot product, so cross product dot u or v dot u times v is equal to 0 because they're 90 degrees and cosine 90 is 0. So yeah, there you go. That is for cross product. I'll show you some equations relating to cross product. So, let's see equations. All right. Area of two vectors, or of the triangle of two vectors. So suppose you have two vectors here, A and B, and you're trying to get the area between these vectors. The way to do that, say you don't have the angle or anything, would and you only have I see. Okay, look. The easy way to do this is get the cross product of both of them and divide it by 2. Because the cross product gets you the area of the parallelogram, and then we just divide it by 2, and it's now the triangle. See that? Anyways, yeah. Now let's extend that logic further into a 3D parallelogram. So, in order for there to be a 3D parallelogram, there must be 3 vectors. So we got vectors B, let's see this. Let's say this is A, and this is vector C. So the equation goes like this. The absolute value of A times B cross C. Now, the reason why there's a absolute value sign is, and it's not a magnitude sign, is because this is a vector, and a vector times a dot product, a uh, dot product of vector, and it turns into a number. So, and this could be negative. These values can be negative. So, but we're trying to get the area, and area can't be negative. So that's why we have the absolute value. Anyways, so the reason why this is the case is first, let's see, BXC would get you an orthogonal. It's hard to draw. Maybe I'll just get two better vectors. Say this is B and C, and this is A, and we're gonna actually draw a coordinate plane. Alright. Pretend this other axis is not where B is at. Alright. So EXC will get you this parallelogram right here, and then there's gonna be an orthogonal thing around like here, I guess. I think it might be like that, or at the very least it's gonna be also perpendicular to this parallelogram. So I'm gonna try to make it look like it's perpendicular to a parallelogram, because drawing it from here doesn't look right. So I think around here is BXC, the vector BXC, and from here we can we're getting the area of a 3D parallelogram. I don't know if I was saying that or not. It's called a parallelepiped or something like that. I have no clue. So we're getting area of this kind of shape. I don't know what a parallelepiped looks like, but we're probably gonna have to use this to here to the vector right there, and then there's a vector right there. That's parallel to that. It's parallel to that. It's parallel to that. Connects. So we're probably gonna do it like that, but in order to create this shape, we have to get BXC, which is also the area of this thing, to dot product with A, so then we can get the area of the full shape. Don't ask me how. Just know that it does this going to this, or the whatever aligning angle, whatever, is equal to this somehow. I have no clue. Somehow this and this are related, and when you dot product it, you get this. So yeah, somehow. Anyways, that's the end.